Hello, how do we go about solving this equation? Well, if we note that 4 is equal to 2 squared, then we can write that 4 to the x is 2 squared to the x, which we can write as 2 to the x squared. Likewise, 4 to the minus x, we can substitute as 2 to the x to minus 2. So now we can rewrite our equation, and we can now use y is 2 to the x. So substituting, in the original equation, we have 8y squared add 1 over y squared minus 54 y add 1 over y add 101 equal to 0. But further to this, in order to simplify this, we can make another substitution. We can let y, or z, sorry, as equal to y add 1 over y. So we can simplify our second equation. So this is the original, and we have here in y, and now we have a substitution with z. So now 2 becomes 8 into z squared minus 54z add 85. And this is equal to 0. And so now we call this equation 3. Now this is part 1 of the problem. I'll be doing 2 other parts and 2 separate videos. Just to recap what we've done, we start off here with the original equation, and I've showed you here how I arrived at the substitution y is equal to 2 raised to the power of x, simply because we can write 4 to the x as 2 to the x raised to 2 all squared, and 4 to the minus x raised to 2, written as 2 to the x raised to the minus 2. So we substitute for y in this equation, in the original equation, and we make another substitution here for z to simplify this. We have z is y add 1 over y. So y squared add 1 over y squared becomes z squared. And here we have minus 54 z. As we simplify this, we have now a constant of 85. So here finally, so remove these brackets, no brackets here, we have our quadratic 8z squared minus 54z at 85. In the next video, I'll be solving for z, and we're actually going to do in the reverse. We're going to solve for z first, then we solve for y, and then finally for x, which is the original unknown. Thanks for watching. I'm Alistair. Right, if you recall from the first video, part 1, this is equation 3. So now we're going to work in the reverse. Here we'll solve this quadratic in Z and find the two values of Z that satisfy this quadratic. So we can rewrite this 8Z squared as minus 34Z minus 20Z add 85 is equal to 0. And further to this, we can factorize this 2Z into 4Z minus 17 minus 5 into 4Z minus 17 equals 0. And finally, 4Z minus 17, 2Z minus 5 equals 0. So this gives us two values. Z is equal to 17 over 4 and Z equal to 5 over 2. But in addition to this, we have to evaluate what Z is. And we know we're given in part 1 video that Z is equal to Y add 1 over Y. And so now we can calculate for Y here. We know we can write this now as 17 over 4. So we're doing it for this value of Z, and then we'll follow it by the second value of Z. So this is equal to Y squared add 1 over Y. So all I've done is turn this into a single fraction by multiplying across here to get Y squared. So it's Y squared 1 over Y. And this allows us to write this being equal to 17 Y minus 4 Y squared add 4. So 17Y is equal to 4Y squared add 4. We cross multiply here, 17Y equal to 4Y squared add 4. And we can rearrange this as 4Y squared minus 17Y add 4 is equal to 0. Now we're solving this quadratic in Y, which allows us to factorize it as Y minus 4 to 4Y minus 1 equals 0, which gives us Y equal to 4 and Y equal to a quarter. So this brings us to the end of part 2. In the next part, I'll be calculating the remaining values for Y using in the next case we'll be using 5 over 2. So we used one value of Z being 17 over 4. The next value of Z calculated was 5 over 2, and that will give us 2 additional values for Y. And then finally we'll calculate the values for X. Thanks for watching. I'm Alistair. Right, our next value of Z was 5 over 2. And so now we use 5 over 2 along with Y squared add 1 over Y, which gives us the quadratic 2Y squared minus 5Y add 2 equals 0. We factorize this, we have y minus 2, 2y minus 1 equal to 0, giving us the values y equal to 2 and y equal to a half. Right, just to show you where we are, we now have these four values of y. We had y at 4 and a quarter and 2 and a half. And just to recap you from the first video, we had that y is equal to 2 to the x. So now we can calculate finally the values of x. Here, initially we have, we use y equal to 4, substituting into this equation y is equal to 2 to the x. So y is equal, 4 is equal to 2 to the x. This implies that x is equal to 2. If we have a quarter, which is y is equal to 2 to the x, this implies that x is equal to 2 to the minus 2. If we have, now we're using values of y equal to 2 and a half. We have 2 is equal to 2 to the x. This implies that x is equal to 1. And finally, a half is equal to 2 to the x, which implies that x is equal to minus 1. Just a mistake here. We have that x is actually minus 2. Because if we raise 2 to the minus 2, we'll get a quarter. So these are the values of x. We have 2, minus 2, 1, and minus 1. So finally, we've solved our original equation. And these are the solutions. 2, minus 2, 1, or minus 1. Thanks for watching. I'm Alistair. Hi, how do we go about solving this system of equations? Well, at first glance, it looks like a complicated system, but if we look a bit closer, we'll be able to see some patterns emerging. If we look at equations 2 and 3, the coefficients on the left-hand side we're looking at here, 8, 4, 6, and 2. And we have them in reverse order for 3, 8, 4, 6, and 2. So for equations 2 and 3, we have similar coefficients. And then in reverse order for one of them. If we look at 1 and 4, we have coefficients 1, 7, 3, and 5. And we have the reverse here, 5, 3, 7, and 1. So 1 and 4 also a similar pattern emerging. If we look at the right-hand side, now we have equations 2 and 4 with similar right-hand sides, and opposites for 1 and 3, opposite sides. Now if we add 1 and 4, so if we add equation 1 and 4, and I urge you to go through this, we have 6 into x add u, add 10 into y add v, that's equal to 0. And if we add 2 and 3. So equation 2 and equation 3. This gives us 10 into x add u add 10 into y add v equal to 0. Now, we can just solve this by inspection. If this equation is equivalent to 0, then both x add u and y add v must be 0. Same for this equation. So our solutions are x add u is equal to 0 and y add v is equal to 0. Right, this is the end of part 1. I'll see you in part 2 for the rest of this problem. Thanks, and see you in the next video. Hi, welcome to part 2. Now, since we know this, we arrived at these two solutions, x add u equal to 0 and y add v equal to 0 in part 1. We can write that u now is equal to minus x, and this implies that v is equal to minus y. Now if we substitute substituting for u and v in the equations 1 and 2, what do we get? We have x add 7y minus 3y minus 5x is equal to 16, and 8x add 4y minus 6y minus 2x equal to negative 16. When we simplify these two, we have minus 4x add 4y is equal to 16, and 6x minus 2y is equal to negative 16. So now we have our system of equations 1 to 4 been reduced to just these two equations here. So we have a set of simultaneous equations which you can solve. We'll leave the first equation as it is. The second equation will multiply by 2, 12x minus 4y minus 32, and now we'll add equation, the first equation to the second equation to give us 8x as equal to negative 16. Which implies that x is equal to negative 2. And if we substitute x as negative 2 into the first equation, we have y is equal to 2. And if we use these two equations, u is equal to minus x, we can work out what x is and also what v is. So u is minus x, which is minus times minus 2. So u is equal to 2. And v is minus y, which is minus 1 times 2, which gives us negative 2. So these are our solutions. X equal to negative 2, y equal to 2, u equal to 2, and v equal to negative 2. Please check these values to confirm that they are indeed solutions to these, or to this system of equations. Thanks for watching. I'm Alistair.